Today our topic is related to the action potential in heart. So let's discuss the action potential in heart and how actions potentials are generated in the heart. So we know that the conducting system of the heart is consist of SA node, AV node and Purkinje system. Now suppose this is your heart, this circle representing your heart, and these lines are representing your right of the heart and left of the heart. So suppose this is the right atrium and this is the left atrium, and suppose this is the right ventricle and suppose this is the left ventricle, and these are the conducting system of the heart. Suppose this is SA node, this is AV node, and this is the bundle of His as I have written here, and this is the left bundle branch and this is the right bundle branch. So how action potentials travel in the heart? So first action potential is generated by the SA node, then it goes toward the AV node, and then finally comes the turn of Purkinje system. तो सबसे पहले SA नोड में एक्शन पोटेंशियल जनरेट होता है, फिर AV नोड की तरफ जाता है, एंड देन फाइनली कम्स द Purkinje system. So how action potentials travel in the heart from SA node, then AV node, and then finally Purkinje system. Now let me ask another question. What are the basics of the action potential? So we know there is a resting membrane potential, then comes the wave of depolarization, then peak of depolarization, then wave of repolarization, hyperpolarization, and then again comes the turn of resting membrane potential. Now if you do not know about the action potentials, basics of action potentials, how they are generated, how they are travel, so click on the I button and clear your basics. So let me ask another question. What are the specialities of the conducting system? So SA node has a speciality of the automaticity, AV node has a speciality of slow conduction, and Purkinje system has a speciality of the fast conduction. So what is automaticity? Ability to generate action potentials or tendency to undergo the depolarization automatically. It is known as automaticity. To be very specific, what is automaticity? The specific definition is the ability to produce action potentials spontaneously without any stimulus. These are the main keywords. Without any stimulus, the ability to generate action potentials without any stimulus, spontaneously generation of action potentials is known as automaticity. And SA node, AV node, Purkinje system all have the capacity of the automaticity, but SA node, to be very specific, SA node is very specialized in automaticity, though all other also have property of automaticity, but the speciality of SA node, or we can say that which one of the structures is very specialized in automaticity, that one is SA node, because it is the pacemaker of the heart. It is the pacemaker of the heart, and it controls the rhythm of the heart. Okay, now then what is the speciality of the AV node? It is specialized in slow conduction. Now why it is slow in conduction, why it is specialized in slow conduction, we will see later. Now what is the speciality of the Purkinje system? Its speciality is fast conduction. Why it is specialized in fast conduction, we will see later. Now let's come on the next slide. Okay, so why AV node is specialized in slow conduction, and why Purkinje system? The counter question is why Purkinje system is specialized in fast conduction. So what are the key differences? AV node has small cells, means they have smaller diameter cells, and Purkinje system has larger cells, means they have larger diameter cells. Now AV node has high cellular density. AV node has high cellular density, and Purkinje system has low cellular or small cellular density. Let's come on next slide and see it more clearly. Now action potentials. traveling of action potentials in case of AV node. In case of AV node, it is perpendicular. This sign is representing the perpendicular. ठीक है, this sign represents the perpendicularity. Okay, so action potentials in the AV node travels in a perpendicular direction to the arrangement of the cell, and the action potentials travel parallel to the arrangement of the cell in case of Purkinje system and Purkinje cells, which make it specialized in fast conduction. Now let's see some diagrams to understand it more clearly. So this is the AV node, this is the Purkinje system. Now suppose this is the AV node and these are the AV nodal cells. These are the AV nodal cells. These circles are representing the AV nodal cells. So, and suppose this is the action potential. The black one is the wave of the action potential. So we can see the wave of the action potential is perpendicular to the arrangement of the cell, But in case of the Purkinje fiber, the action potential is traveling along the direction of the arrangement of the cell. So when the action potential is traveling perpendicular to the arrangement of the cell, this perpendicular arrangement of the cells make the action potential speed or velocity a little bit slower or very slower, we can say, in case of the AV node. But in case of the Purkinje fiber, the cells are arranged not perpendicular but parallel to the direction of the action potentials, which make it faster, or which make it specialized in faster conduction with faster velocity. Okay, approximately 2 to 4 meter per second, Okay, now comes on the automaticity. So we know that SA node, and it's one of the speciality that it is a pacemaker of the heart. And why it is a pacemaker of the heart? Because it has a speciality of automaticity. Okay, and though all other have automaticity, AV node is all have the also property of automaticity. Purkinje system has also the property of automaticity, but the conduction of the heart, or we can say first action potential, is generated in the SA node. So it is involved in controlling the rhythm of the heart. Which is involved in controlling the rhythm of the hearts, or which structure controls the rhythm of the heart? So it is the SA node. Now consider that this one is your SA node, and one SA node has a lot of cells. Now one of the cell I have drawn here. Now suppose this is one of the SA nodal cells. Okay, and these are the calcium dependent these are the voltage gated calcium channels. These red ones are, okay, and these both are the calcium voltage gated calcium channels. And suppose this one is a sodium leaky channel, Now one of the another property related to the acinodal cells, that their resting membrane potential is not stable. Their resting membrane potential have tendency to move towards a threshold potential, and we know that threshold potential is a potential where action potentials can be generated, where the voltage gated channels can be opened properly. So suppose that these are the sodium leaky channels, and there is a continuous influx of the sodium through these sodium leaky channels inside of the acinodal cells, and we know that sodium is a positively charged ion. So when the positively charged ions are continuously going inside of the acinodal cells, so we can say that positivity is coming inside of the cell, which makes inside of the membrane of the acinodal cell a little bit positive. So suppose resting membrane potential is minus 60 millivolts and threshold potential is minus 40 millivolts. So as soon as the sodium ions or positive ions are continuously coming inside of the acinodal cells, it makes the inside of the cell a little bit positive. So resting membrane potential is more negative. But when the sodiums are continuously influxing inside of the acinodal cell, the resting membrane potential start becoming less negative or a little bit positive, which is minus 40. Okay, so actually जो -40 है और -60, जितनी बड़ी रकम होगी उसके साथ माइनस जब लग जाए तो वो उतना ही नेगेटिव होगा. 40 60 के मुकाबले में छोटा है, इसके साथ माइनस लग गया तो इसका मतलब ये 60 के मुकाबले में थोड़ा बहुत पॉजिटिव है. ठीक है. So as soon as the sodiums are continuously influxing, resting membrane potential start becoming a little bit positive or going towards the threshold potential. And when the threshold potential is achieved, at this point where I draw the pink point, okay, so these voltage gated put calcium channels open, these voltage gated calcium channels open, and calcium start influxing, inside of the cell, and there is a threshold, and there is a upstroke of the action, and there is a upstroke of the depolarization. So first, as soon as the sodium is continuously influxing, the resting membrane potential start moving towards the threshold potential, and as soon as the threshold potential is achieved, there is a sudden upstroke, sudden upstroke towards the peak of the action potential, and then again repolarization occurs, and then the same phenomena occurring again and again. Now one of the main point I want to tell you is related to the depolarization, that we have seen that in case of the SA node, depolarization is calcium dependent, not sodium dependent, okay, remember it. Now acinodal cells, so we have seen that acinodal cell resting membrane potential is not stable. Acinodal cell resting membrane potential have tendency to go towards the threshold potential automatically without any stimulus, okay, and this is the automaticity. But why? So answer is sodium influx, because through the sodium leaky channel, sodium ions are continuously influxing, makes the resting membrane potential a little bit positive, and resting membrane potential start going towards a threshold potential, and as soon as a threshold potential is achieved, so there is a sudden upstroke, towards the in case of depolarization, and depolarization is achieved, okay, and then whole phenomena is going or occurs again and again. Okay, now up to now we have understand that how action potentials travel. So action potential are generated by the SA node and then go towards the AV node, but before going towards the AV node, there's a part of the heart known as atria of the heart. So first action potentials are produced by the SA node, then they spread over the atria, then muscles of the atrium are contracted, and then the wave of depolarization going towards the AV node. Now the next question is how action potentials are transmitted towards ventricles from AV node. So first action potential generated by SA node then spreads over the atria. Now how action potentials go towards the ventricles from the atria, so the answer is through AV node. Remember, AV node is only the electrical window, through which the action potentials can travel from the atria towards the ventricles. Now suppose this is a cross section of your heart, and we are seeing heart from the above side, this is the top view of your heart, and this is your tricuspid valve, right atrioventricular valve, this is your right AV valve, okay, which is a tricuspid valve. This is the left atrioventricular valve, L representing the left. This is a pulmonary valve, and this is one is the aortic valve, Now we know that there is a skeleton in the heart, which is a fibrous skeleton of the heart, Now one of the property of the fibrous skeleton of the heart that it provides insulation. So electricity or action potentials cannot travel through this fibrous skeleton of the heart. Now where this is fibrous skeleton of the heart is present, so this one is your fibrous skeleton of your heart, okay. This one is a fibrous skeleton of the heart. This green one is also the fibrous skeleton of the heart around the left AV valve, and this is again the fibrous skeleton of the heart or fibrous ring near the or around the right AV valve. Now there is another fibrous skeleton of the heart which is present around the aortic valve. Here also the fibrous skeleton or fibrous ring is present around the pulmonary valve, okay. Now there are two trigons in the fibrous skeletons are present. There are two trigons. There are two triangular structures are present in the fibrous skeleton of the heart. Now, first one is this one, and second one is this one. Okay, so this one is the right trigon of the heart, right trigon of the fibrous skeleton of the heart, right trigon, right trigon, and this one is the left trigon. This one is the left trigon. Okay, so now let's draw some graphs. Up to now we have understand what is the fibrous skeleton of the heart and what is the property of the fibrous skeleton of the heart, which is insulation. So how action potentials are traveled, एक्शन पोटेंशियल्स कैसे एट्रिया से वेंट्रिकल्स की तरफ जाते हैं थ्रू द AV node. Through the AV node is only the electrical window which is present at the junction of the atria and the ventricles. Now let's draw the graphs of the SA node and AV node. Now remember कि जिस तरह से SA node के ग्राफ होता है एक्शन पोटेंशियल का, उसी तरह से AV node का ग्राफ भी होता है. Now see, this line representing the resting membrane potential, this line representing the threshold potential. Now as soon as the sodium is influxing, threshold resting membrane potential start moving towards the threshold potential. As soon as the threshold potential is achieved, then wave of depolarization occur, then repolarization, and then the whole phenomenon is going on and on. And in case of the AV node, same thing is happen. Okay, this line representing resting membrane potential, this line is representing threshold potential. Sodium is in flux, resting membrane potential start moving towards the threshold potential, and as soon as the threshold potential is achieved, sudden upstroke of depolarization occurs, and then again repolarization occurs, and then all phenomena going again and again. Now what is the point of difference? So if we see this line, when the action potential is moving towards a threshold potential, so एक ढलवान बनी हुई है. जिस तरह से पहाड़ है, पहाड़ों की ढलवान होती है, उसी तरह एक्शन पोटेंशियल्स के ग्राफ में भी हमने स्लोप्स को देखना, ढलवानों को देखना. सो अगर देखा जाए इसकी स्लोप ज्यादा है, रिलेटिवली एवी नोट की स्लोप जरा कम है. यहाँ अगर इसको पहाड़ माना जाए तो इस वाली स्लोप पे चढ़ना आसान है क्योंकि थोड़ी सी नीचे, लेकिन ये बिल्कुल ही स्ट्रेट है तो इस पे चढ़ना जरा मुश्किल है. ठीक है. सो again the slope of the SA node is high, and AV node slope is a little bit less. Now let's see the Purkinje system slope. So Purkinje system slope की अगर मैं बात करूं तो बहुत कम है. सबसे ज्यादा स्लोप किसकी है? SA node की, उसके बाद AV node की, then finally comes the turn of Purkinje system. Now why the slope of the SA node is high? So the answer is written on the next slide, that why SA node has high slope, because of the highest cationic flux. More will be the cationic influx, more will be the sodium influx, more will be the slope, or we can say more will be the tendency. Slope is more, actually what is represented by the slope is representing the tendency to move towards the threshold potential. So if the slope is high, then there will be more tendency to go towards the threshold potential, and then action potential will be generated more rapidly. So SA nodal cells have more cationic influx, so it means it has more slope, it means it has more tendency to go towards the threshold potential. So action potentials can be generated more rapidly as compared to the SA node or Purkinje fiber or Purkinje system. Now other point of difference, what are the other point of difference? So SA nodal cells depolarization is calcium dependent. In case of AV node, depolarization is again calcium dependent, but in case of Purkinje system, depolarization is sodium dependent. Okay. Now another point of differences are there again, that in case of SA node nodal graphs, plateau phase is UAE, plateau phase is absent. In case of AV nodal cell graphs, again plateau phase is absent. In case of Purkinje system, again plateau phase is absent. What is plateau phase? We will see later, but plateau phase is present in atria and ventricles, atria and ventricles. Okay, atria and ventricles. Now, if the SA node, now we know that SA node is the pacemaker of the heart and it is controlling the rhythm of the heart. If the SA node is destroyed, then the rhythm will be controlled by the AV node. If the AV node is destroyed, then the rhythm will be controlled by the Purkinje system. Then the rhythm will be controlled by the Purkinje system. Okay, now we know that from first action potential generated by the SA node, then action potential spread over the atria and then go towards the AV node, which is only the electrical window present at the junction of the atria and the ventricles, and from the AV node it will go towards the Purkinje fiber. It will go towards the Purkinje fibers. Now suppose these are the atrial cells, and one of the atrial cells I have drawn here. Now again, these are the sodium leaky channels. These are the sodium leaky channels, and these are the voltage gated sodium channels, and these are the calcium, and this green one is a potassium channel. Now to understand the graphs, actually what the action potential graphs want to say, हमें इनसे क्या पता चलता है. So suppose this is an action potential graph. This is an action potential graph, and this line is representing the plateau. This line is representing the plateau which is absent in SA node, which is absent in AV node, which is absent in Purkinje fiber. ठीक है, absent, but present in atria and ventricles. Now actually these graphs can be of any type. This is the graph with plateau phase, and without plateau phase we know that graphs are like this. Okay, so actually these graphs are representing change in action potential, change in membrane potential. Now if you want to know what is the membrane potential, how action potentials are generated, or you want to clear the basics of the action potential now, so I have make another video already related to the action potentials, how they are generated, how they are traveled. So I will give the link in the description below. Click on the link and clear your basics. So what the action potential graph want to say, they are representing the change in the membrane potentials, how membrane potentials are changing side by side. Okay, so now suppose now we know that SA node, AV node and Purkinje system resting membrane potentials are not stable. They are not stable. Their resting membrane potential are not stable. But atria and ventricle resting membrane potential, the cells of the atria and ventricles resting membrane potential is stable. We can see it is not fluctuating. It is not moving like this. It is not moving. Suppose this is the resting membrane potential, this is threshold potential. It is not fluctuating like this. Okay, it is continuously on the baseline. It is continuously on the baseline. It is not fluctuating like in the SA node, AV node and the Purkinje system. Now suppose that SA node generate the first action potential, and this action potential spreads over the atria. When it is spread over the atria, so sodium leaky channels open and there is an influx of the sodium, and as soon as the sodium is influxing, the resting membrane potential become fluctuating. Then before it is not fluctuating, but as soon as the sodium is continuously influxing after the generation of the action potential from the SA node, so it becomes fluctuating and start moving towards a threshold potential, and as soon as the threshold potential is achieved, voltage gated sodium channels open. First they are in this configuration, then they are converted into this configuration in which the activating gate of the voltage gated sodium channel is open, and sodium start moving inside of the cell, and we know that sodium is the positive ion. So as soon as the positive ions are going inside of the cell, resting membrane potential start becoming positive, and there is a sudden upstroke of the depolarization. Now, as soon as the depolarization is achieved, these voltage gated sodium channels closed, okay, and then there is an influx of calcium and efflux of sodium potassium start. So one positive ion is coming inside of the cell and one positive ion is going outside of the cell. So at this phase, there will be no net change, in the membrane potential, and when there is no net change in the membrane potential, it is represented by the straight line, which is the plateau phase, and plateau phase is absent in AV node, SA node and Purkinje system. Okay, and then again voltage gated potassium channels open, and there is a efflux of the potassium, and repolarization occur. So and same will be for सेल्स ऑफ वेंट्रिकल. सो अगर आपने ऐसे नोड के एक्शन पोटेंशियल को समझ लिया, उसी तरह होगा एवी नोड के सेल्स में, बस स्लोप का थोड़ा डिफरेंस होगा, कुछ थोड़े और अदर डिफरेंस होंगे. ठीक है. और इसी तरह अगर आपने एट्रिया के एक्शन पोटेंशियल को समझ लिया तो बिल्कुल ही वैसे ही एक्शन पोटेंशियल वेंट्रिकल्स में प्रोड्यूस होने वाले. नाउ मैंने एक बात कही थी कि AV node is specialized in slow conduction. So why? What is the purpose of this? So that ventricles, when the AV node is specialized in slow conduction, so it holds a current, for some seconds. Okay, it holds a current. When it holds a current, action potentials cannot go towards the ventricles. When action potentials cannot go towards the ventricles, so there will be a proper or sufficient filling of the ventricles. देखें, जब एट्रिया में sufficient filling of ventricles, suppose this is your heart and this is your AV node and this is your SA node. So जब SA node तक AV node में करंट आएगा और होल्ड हो जाएगा, आगे नहीं जा पाएगा, तो एट्रिया से ब्लड सुकून से वेंट्रिकल्स में फिल हो पाएगा. Blood from the atria will be filled sufficiently, or to sufficient extent will be filled up to the sufficient extent into the ventricles. Sufficient extent तक एट्रिया से वेंट्रिकल्स तक ब्लड को फिल किया जाएगा, वेंट्रिकल्स की प्रॉपर फिलिंग होगी और फिर ही करंट एवी नोड से कहां स्प्रेड होगा? वेंट्रिकल्स पे स्प्रेड होगा. कैसे स्प्रेड होगा? पर्किंजे सिस्टम के थ्रू, लेफ्ट बंडल ब्रांच और राइट बंडल ब्रांच के थ्रू, और फिर वेंट्रिकल्स कॉन्ट्रैक्ट करेंगे. So this is a purpose of the AV nodal delay. This is a purpose of slow conduction of AV node. So I hope you have cleared all your concepts. आपसे मुलाकात होगी अगली वीडियो में. अल्लाह हाफिज.